Hey, hope you guys are doing well. Thanks for checking in with this strange little video clip. It's trying to model if it is really a physical modeling of a chemical equilibrium or any kind of equilibrium. In this cylinder on the left, I have the reactants, about 50 milliliters of reactant. On this cylinder on the right, I have no products. I have a straw of equal diameter sticking into each one of them. I'll place my thumb over the top, kind of pinching off the liquid like you do when you play with your soda, and I'll pick up the straws. Let me just go ahead and play it here. Get her going. There we go. So yeah, the forward process might go from left to right, and in the beginning my straw in the left hand reactant cylinder picks up a whole bunch of liquid and transfers it over to the products vessel. But then after just a little while, there's a little bit of product over here. Then my straw in the right will also pick up and bring over some liquid back to the original reactant side. Well, without too much effort, I'm pretty sure you can guess what's going to happen. Sorry, it looks a little bit choppy here. I just made this in the lab a few minutes ago. Let's see. If I started with 50 milliliters of reactant, and both straws are of equal diameter, I wonder how much product and reactant I'll end up with in the end. Will I reach a balanced state? Will I reach a place where I have equal amounts? And the answer is, if the straws are the same size... Uh-oh. Did you see what I just did? Should I rewind it? I don't know if I should rewind it. Did I spill some? I'm going to confuse my computer here. Oh, I missed it. Let me see that again. I'm going to be silly and careless. Would it matter if I spilled some out of the container? My video's too choppy. The answer is I did just spill some. So if I spilled some, can I still reach a balanced mixture? Well, if I spill, honestly, I think I just spilled about 4 or 5 milliliters. So if I had 50 in the beginning, and I didn't spill any, I'm guessing I'd be close to 25 and 25, since the straws are the same diameter. But since I did spill some, will I still reach an equilibrium state? If the straws are the same diameter, I think I'll still reach an equal amount steady state. And not only that, I'll reach an equilibrium position where the forwards and the backwards transfer is still equal. But again, like I said, because I spilled about 4 or 5 milliliters, I'm fairly confident. I did it on purpose. Like, what if you had a reaction vessel that leaked a little bit? Could you still reach an equilibrium balanced state within that reaction vessel? This is interesting. So I started with 50, but I spilled about 4 or 5. So instead of 25 and 25, I bumped my camera. Sorry about that. Let me just go back here a little bit. Since I spilled a little bit, how about we say 22 and 22, or 23 and 23, that'd be 46 altogether. So the answer is yeah, I can reach a balanced state. Let me go on. So what would that mean? That would mean I start with reactants, and they go down, 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 down. And I start with no products, but that goes up, 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 up. In my straw modeling, these two would actually, the concentrations would actually equilibrate. So these two would be at the same level. But as in this chemical model of chemical reactants and products, the backwards reaction speeds up, the forwards reaction speed slows down. I reach an equilibrium state. It looks like pretty quickly, like maybe in here or something. Although if you want to be careful, maybe say wait a while for it to reach an equilibrium. In my modeling, these two would have equilibrated at 50-50, or at the halfway point between the two. Here's another one. Shoot, I suppose this would be like if I had one cylinder with certain volume to start with, another cylinder with a certain volume. So a third cylinder one cylinder here, one cylinder here of reactants, maybe say a red fluid and a dark fluid, and I had nothing in a third cylinder, and then these two picked up and came over and produced some of this, but then this grew, that would be contributing to this backwards a little bit, but it eventually still reached an equilibrium. So rarely actually are the equilibrium amounts the same. So rarely is this the same as this, would be the same as this, but always when you reach an equilibrium, the rates of the forwards and the rates of the backwards equal. So at equilibrium, this stays the same, the rates forwards and backwards stay the same, and the concentrations are no longer changing, although they might not be the same as, here's another one. In this one I have a very fat straw right here, it's actually glass, and in this one I have a skinny straw. Can I still reach, loading, can I still reach an equilibrium state? Will I still be able, oh goodness, oh yeah, my volume over here you might have noticed was above 50, but that's only because my glass straw is so large it took up some volume and raised the blue up to here somewhere. But if I start with 50 milliliters of blue here and no blue over here, you see where I'm going. Question, will I still reach an equilibrium? Oh darn, it stopped. Sorry about that. Will I still be able to reach an equilibrium state? Let me fast forward a little bit if I can. Well, the answer is yes, I'll still reach a steady state. Or in other words, I mean, I'll reach a place where I have the forward and backward transfers being equal. But as you can see, that doesn't mean if your straws are different sizes or the, say, propensity for the reactants producing the products is larger than the propensity, I'd have to define that word, for the products coming backwards to make the reactants. Yeah. So let's see. If we were to figure out an equilibrium constant for this, it would be products over reactants. Since I have more products than reactants, I'm going to say this equilibrium constant is larger than 1. In the previous example, the equilibrium constant would have been exactly equal to 1, where I have the straws of equal size, and I reach a 50-50 balanced mixture. But in this one, I'm not going to get there. In this one, I do believe since this straw is much larger and thicker, this volume will be larger. I'll have more products at the end of the equilibrium state. But the transfer is still the same. I paused it for a second. Let me keep going right there. No, I'm going to drop that in. So well, I wish I could pause it here with the straws out of the water and just have had dropped their container. Darn it. Anyways, I see this is larger. Let's say this is 35. Let's say this is 15, something like that. 35 over 15 gives you a constant. Let's see what else can I say about that. So again, rarely are the equilibrium amounts the same, but if this straw is fatter and picks up this liquid, I'm saying when equilibrium is reached, this amount of liquid transferring forwards will be equal to this amount of liquid in this straw, which is skinnier yet taller, coming backwards over to here. I don't know if that's 3 milliliters forwards and 3 milliliters backwards, but in any case, I don't know if that makes any sense. Similarly, and lastly, along the same lines, again, the rate is the rate for the forward reaction and the rate for the backwards reaction. Finally, equilibrate at equilibrium, and not necessarily are the amounts the same. Just like in the straw thing, I had more products at the end and fewer reactants because the forward straw was larger. Maybe that means the propensity of the likeliness of that forward reaction is greater in those particular pressure, temperature conditions. Well, I don't know if that makes any sense or if you're just more confused now, but let me know. Ask questions. Thanks, guys.